Hello, everyone, and welcome to the Audio Product Development Alliance. I'm Roger Shively from Shively Acoustics International, and this is the APDA, your gateway to audio product development. It's the only organization focused exclusively on audio product development education, providing current and relevant content that can be experienced in person, live online, like we are now, and on demand later, combined with valuable cross-industry, knowledgeable sharing. The APDA serves as a networking hub for the audio industry and offering access to experts and colleagues from our professional development. The APDA is where we come to learn how to build relationships and build better audio products. We talk about design, measurement, simulation, supply chain, automotive applications, headphones, earphones, wireless technologies, and we do touch on industry standards, and we'll be talking about those last two today. Online with us today from the APDA is Steve Willenberg from LinkPlay. Hi, Steve. How you doing?
Good. How you doing, Roger?
All right. And also
Good.
with us today from DB Enterprises and the THD podcast, Dave Lindberg. How you doing, Dave?
Hey, good morning, everybody.
The rest of our members, namely Joa Martins from Audio Express, our media partner, and Adam Levinson from Levinson Consulting, are in Shanghai at the moment at the Global Audio Summit. So if you're there, happen to say hello to them. And thank you for Spencer running this in the background for us today on the live talk. We are recording this so we can watch it a little bit later. So check it out on our YouTube channel and share it, like us. We do have some APDA events coming up in the next month. In April the 8th, we have Fraunhofer talking about sound personalization techniques. And May 6th, we're going to start talking about manufacturing in South Pacific Asia.
Yep.
And later in June, we'll have the Audio Foundry here and Bluetooth LE audio in July. So, and I think we'll be revisiting the tariffs again in August. So today we're welcoming in one of those colleagues that we talked about, and that's Ethan Wetzell. How you
Hello.
doing, Ethan? Welcome.
I'm doing
Uh,
fantastic. Thanks for having me.
yeah, good. Ethan's
Yeah.
a platform strategist for Bosch Communication Systems, and you are also the market chair for the OCA Alliance. And that OCA Alliance is a trade organization that was formed to promote the AES 70 standard and open control architecture, which is the OCA ecosystem. And so that is a control solution for professional media networking applications. And today, our topic is better options for open control and monitoring. And that's the topic of device and system control in wired and wireless connected devices, and how it covers a lot more than we might think initially. So we're going to bring you in for this topic, but I think in at the ISC in Barcelona just recently, the APDA and OCA promoted a networking event, and it motivated some really productive conversations, I think, at that time between the developers, technology providers, engineering companies, and manufacturers. And it was pretty clear how companies from completely different application segments in residential and commercial and professional AV seemed determined to expand connectivity by embracing some of the AES 70 based controls. So we thought it would be a great idea to maybe take another little bit deeper dive today and on a wider audience. So that's kind of what we've got you here, Ethan. And anybody who wants to bring a message into the chat online, please let us know, and we'll pass that on to Ethan and then the crew. So without anything else, welcome, and we're ready to go. So let's start the conversation.
Fantastic. Well, I'm going to begin by making the possibly controversial statement that a developer's choice of control and control architecture is fundamentally one of the most important product and design decisions that can be made throughout the entire life cycle of the product. More so than sometimes the market or the core functionality, because this is what actually brings to life and enables the product itself. So we'll talk a little bit more about that and why this is really such a critical and key element to your product and your technology as we dig into this. And once again, I'd like to extend my thanks to the APDA and all of you who are joining us live for having this webinar. We'll try to keep this interesting and conversational, and we'll go through it and hopefully have some fun. So just a real quick agenda that I'd like to take everybody through as we go through this session. I want to start out talking about technology, standards, and solutions. Oh my, what are the building blocks of all of these things that we're talking about in this wonderful alphabet soup of acronyms and other things that you can find in these long, winding white papers, and how do they relate to each other? I think that sort of helps cut through some of the fog as to what to pay attention to and maybe what to pay less attention to as you're going through and making some of these product and technology decisions. The next thing I want to get into is what exactly we mean when we're talking about control. Certainly people will sometimes think of this as, toggling a mute button or adjusting a gain level, and that absolutely is true. But there's a lot more to control, particularly as it comes to a holistic product design and product vision than sometimes we may think. And one of the reasons that I say control is so critical is because some of those details can become really big design challenges if they're left to later in the product life cycle or development cycle. So thinking about those things up front and going in with your eyes open can be really beneficial in making sure that you can have the most effective and efficient development process to get your product to market and get those sales rolling in as quickly as we can. I'll continue on after that with a bit of an overview to the AS70 standard itself, some of the elements and design philosophies that we put into the creation of the technology, and then I'll wrap up with a quick overview of the tools and resources that we as a trade association make available to people out there who are wanting to learn a little bit more about the technology and get their hands on some technical and digital goodies to have some fun.
That's good.
So with no further ado, unless there's any questions before we dive in.
No, let's go ahead.
All right. There is, I think, an unwritten law somewhere in the industry that if you're going to do a presentation or a talk about standards, you are legally required to include this XKCD cartoon. So not wanting to get thrown into standards jail, of course, I had to offer this up as well. But one of the things that I find people getting into this landscape can sometimes struggle with is understanding the building blocks that go into some of these technological underpinnings. The relationship between a protocol, a standard, and a solution. There's sometimes the little s standard and the big S standard, and how do they relate to each other? What's the difference? What has backing and what's just the thing that everybody uses? Sometimes that could become a little bit tricky to untangle and get your head around. It's also sometimes a little bit challenging to understand who exactly is behind all of these different building blocks, who's creating them and developing them and promoting them. This could range from standards bodies to trade associations to manufacturers to people like the APDA or people like you who are watching, who are developing a product. All of these participants play a role in the creation of the technological landscape that we work with and shape the technologies that we have at our disposal and how exactly they get used. And as I say, the intention of all of this is usually very well-meaning, but it can sometimes get a little bit confusing when you go out and try to figure out what exactly something is and how it fits in with a broader landscape. So I like to use this as an example to just talk about a media networking architecture. And when I say media networking, I'm talking about moving content around on a network and having devices present that can distribute it, consume it, or interact with that. And fundamentally, when we talk about a media networking architecture, there's really two fundamental components. We've got the program transport to be able to move the ones and zeros of the audio or video or general content around on the wires. And then we've got the system control, which is how we're going to interact with that and how exactly the devices interoperate with each other on a level that's higher than simply exchanging content between them. These two fundamental components are also supplemented by time services for things like synchronization or playout timing, scheduled events, things like that. And of course, directory services. So discovering devices, finding out capabilities of devices, names, locations, the general characteristics and capabilities of everything that's on the system. And of course, those time services as well as those directory services can have impact on both program and system control. Certainly, there are types of devices out there, for example, wall controllers that may only be focused on the control, but generally speaking, when we're talking about a holistic media networking architecture, we've got these two fundamental elements and then these two complementary services that bring additional functionality to the architecture alongside of it. So let's talk a little bit more about these ingredients that go into some of these technologies. At the very base layer, we've got sort of our atomic or primordial elements, which are the protocols. And a protocol is really a specific set of communication rules or a specific tool that's designed to do a thing. Some examples of these are IEEE 1588, which is specifically designed to deal with timing. These are generally created by standards bodies, the IEEE, the IETF, groups like that are defining these atomic tools that can be used to build up greater and greater things. The superset of the protocols is going to be a standard. So a standard is an agreed upon way of doing things. You can think of this maybe a little bit like a recipe. We're going to take some sugar and we're going to take some salt and we're going to take some flour and I'm going to put them together in a very specific way and then I'm going to publish that recipe for everybody to use the same way in the same manner. So, our bake times are going to be the same. We're going to use the same amount of each ingredient. It's really a fundamental way to put to task those atomic tools that are created by the standards bodies. And some examples of this are things like AES-67, ST2110, AES-70, of course. And you could see in the slide here some examples of those technology components where we're AES-67 rolls up a number of these individual protocols in a very specific and set way so that they can interoperate with each other and do things the same way.
Is it safe?
Go ahead.
No, sorry. Is it safe to say that AES-67 is more like intended for streaming protocols, or is it? How do you define what AES is covering besides these components that you're showing here? What was the purpose at the point when it was created?
I guess the very quick story behind AES-67 is as audio began to make the migration from digital to layer 2 technology to routable IP-based technology in the late aughts and early teens, there were a lot of solutions that came onto the market that were doing fundamentally the same thing, but in sometimes incompatible ways. So you had things like Dante, Ravenna, WheatNet, and. And as you began to sort of break those solutions down into their individual elements, what you would find is a lot of the same technologies or protocols were being used. For example, 1588 was used very commonly across all of those. But the problem that we were running into as an industry is in this stack of technology components that were used in each of those solutions, maybe one or two things would be used slightly differently or use a completely different technology than the other offerings that were out there in the industry, and that broke compatibility. So even though they were trying to do exactly the same thing, and in some cases were 90% using the same technical foundations, because of these little inconsistencies and different technology choices, they wouldn't play together. So the AES looked at that and said, well, gosh, I think we can probably do a little bit better. And they created the initiative to go out and create what would become AES-67, which defined a level of common elements and a common way of doing things and implementing these specific protocols so that you could get compatibility across different solutions. And as part of that, there was a very distinct break as far as what was going to be defined and what was not going to be defined when it came to the AES-67 stack. But the ultimate punchline of this is we wanted the solutions, which were the technologies or products that actually implement the protocols and standards, to be able to talk to each other.
Right.
And a really good example of that would be getting Dante to be able to communicate with Ravenna or QLAN or the Omnio technology suite that Bosch uses in some of our products. So one of the things that I sort of liken the AES-67 to, it is a streaming protocol, so it's designed to move content back and forth. I like to refer to it as sort of a chunk of unterminated, unshielded twisted pair wire. It's
Okay.
really a common foundation of pretty much all of the audio things that we do. It's a standard and well understood solution that everybody uses, but you do still need to add a couple of things on top of it, like discovery and control elements, to really get the most out of it. So we do need to add a couple of other things, but it's this really important underpinning of technologies. And what this winds up doing is you create this sort of hierarchical structure of these protocols, these standards, and these solutions to get these different levels of compatibility and interoperability. So a good example is AES-67 incorporates protocols like IEEE 1588, RTP, and obviously many, many others. But then Dante can serve as sort of a superset that includes the AES-67 elements, but then adds additional things like discovery, tools for audio management, maybe some software tools to be able to make my connections and actually operate the system. And then something like Dante can actually be included into another hierarchy or another hierarchical superset that acts as a solution, such as Bosch's Omnio, where we're adding things like AES-70 for control, we're adding encryption, we're adding some additional redundancy options, additional tools for system management, so on and so on. What this basically means is you as an implementer or a product designer are able to sort of look up and down this technology stack and identify kind of where and what level you want to be compatible. If all we need to do is just be able to exchange audio back and forth, just in pure binary across the wire, I could just implement AES-67 and then I get that compatibility at that audio layer with things like Dante or like Omnio. But if I want to go a little bit higher and get more so we say user or experiential interoperability, things like a common piece of software to be able to make my connections or common monitoring tools, then I can go higher up that stack to have additional interoperability. And instead of just implementing maybe pure AES-67, now I can implement Dante. So I get that higher level of compatibility across devices, but I still have that base level of compatibility to go out to things like Ravenna or QLAN or any number of things. So
Okay.
it's really sort of this nesting doll to take these primordial atomic technology elements, build them up, combine them, agree on how we're going to use them, and then implement that as a more full-featured solution to be able to take to the market.
Okay. So, and then the AES-70 is that control that you're talking about that brings it all
Exactly.
together.
And
Yeah. Okay.
right. So whereas AES-67 is really intended as the transport, AES-70 works as a very convenient counterpart to it to deal with some of these other elements that AES-67 did not address as part of the standardization, such as control, connection management, discovery, and things of that nature.
Got it. That's good. And, I think because, all the networking that we have now is beginning to overlap with what's going on with the consumer. We have single speakers, smart speakers. The speakers are getting smarter, but they're also now becoming more multi-room type of applications. And
Absolutely.
so that control that you're talking about is absolutely necessary. It's essential to getting it to work properly. Yeah.
Well, and this is really a fundamental need for anything that uses any type of media networking.
Yes.
Whether it's something that exists in the pro audio space, in the consumer space, the streaming space, the broadcast space, I fundamentally have that need to move content around the network and then be able to interact with it or do something with it once it actually arrives where I want it to go.
Ethan, do you see a rise of prosumer type products that come out of this to bridge, if you will, the true consumer products with the true pro products? Somewhere in the middle where there's an overlap of these capabilities.
That's a really interesting question. And one of the things that I've observed, and I'm very much coming from the pro space, that's my background, and those are the kinds of products that we make. But what I've definitely seen over the past several years has been sort of this blurring of the lines between what was pro and what was consumer. This is particularly notable in things like video, or when we start talking about things like unified communications, where we have sound bars and other things that were sort of traditionally consumer level audio, either adding features or getting incorporated into pro systems. So yeah, I think we had this situation once upon a time where there was very distinctly a pro category and a consumer category, and you never cross the streams. But I think that's beginning to fade in a lot of applications, not the least of which due to some of these technologies that we're using. So when we start talking about pro technology going into consumer or prosumer level applications, I think that's absolutely relevant. One really good example of that was Ellitone at ISE this year, showing off a residential and arguably consumer level implementation of some of their solutions, but using AES-67 and using AES-70 as the technology underpinnings. So there's very much an overlap between the technological foundation and the endpoints, and I think that's good for everybody.
Yeah, and that gets your product to the market faster. If you're using something that's very compatible with many things, you don't have to worry about working out those details. You have something that's controlled by a standard.
Well, there's a number of advantages that you get from going back to more of a common technology or a standards-based technology, and we'll talk about that a little bit more when we get into some of the underpinnings of the standard itself.
All right, good. All right.
So I think that's a really great segue into digging into what exactly we mean by control. And this is one of those deceptively complex questions and topics that comes up all the time. I think a lot of people, when we first start talking about control, as I said at the beginning, think, okay, it's how I turn things up or down, or it's how I make a mute, or just sort of generally interact with my system. And that's absolutely true, but it goes a lot deeper than I think people often think about right at the beginning, because it's more than just adjusting a parameter. When we start thinking about control in a big picture, holistic way for a device, we're really thinking about the entire architecture of that product. The control architecture really begins to describe and map out not only what a device is capable of, but actually how it does it. So what are the elements of the product? Do I have discrete DSP blocks? Am I interacting with gain stages? Where do I need to think about putting sensors or monitors in my device to be able to get feedback that's useful for the application? Particularly with something like an amplifier. Do I want to read the temperature of a heat sink? Do I want to read the status of a power supply? What are all of the things that are going on within this device that I, as a user, may need to interact with, or I may need to consider in my design up front to make sure that those elements are actually there when it comes time to use it? We need to think about things like, how are events handled? How exactly do I report out or send information from the device or get information into the device? How does it operate within a system? How is it talking to other elements of the system, whether they're hardware-based or software-based? How do I deal with multiple users? How do I deal with concurrency? What happens if two users hit that mute button and they're 10 milliseconds off because they're a room apart? What does the device do? So how exactly does the system work to create a really complete solution? And ultimately, all of that winds up being described by the control architecture. Now, AES-70 is not going to dictate any of this for you, but it's going to give you a very handy guideline and framework for thinking about this within a device. So some examples of control that we run into as product developers are, as I say, adjusting a DSP parameter. That, of course, is a pretty straightforward one. But how do we monitor the device's health? How do we monitor its parameters? Looking at things like VU meters versus general collect faults. How often do I want that information to come through? Where do I want it to go? How do I want to present it? External APIs. What do I offer up to something like a Crestron or a QSys system to be able to interact with it and control it remotely? Custom controllers, those types of things. How do I establish, maintain, and build up media network connections? How do I move the audio back and forth? How do I nail up those audio channels? What is my machine-to-machine interaction? What are my internal functions? Preset recall, scene recall, pre-recorded events, sequences, all of those types of things really feed into what makes up a device's control architecture. So it goes well beyond just that simple mute button or the basic HMI that you're putting onto the device and gets into a much bigger discussion about the product architecture and how this is going to operate once it actually gets into an installation. So AES-70 was really designed as an architecture to create this comprehensive control and monitoring architecture and technology for systems and devices. And it was designed initially, we began working on this in 2009, going way back, but it actually has some underpinnings in an old AES standard known as AES 24, which was done in the 90s. And when we began to undertake the development of the specification, we spent a long time doing a survey of what else was out there in the market. And we'll talk a little bit more about those design considerations. There were some things that were very important to us to do in AES-67, but one of the really important things was, what were we not going to do? What were things that we were specifically going to leave off of the specification? So it is not a transport control. It can live alongside analog audio, digital audio, network audio, video, or nothing. It could just be a simple control as well. It's completely transport and content agnostic as far as things are moving along, so it's very flexible. It's not a device implementation framework. So we're not telling you how to build up your device. We're just providing a way that you can describe it and articulate and begin to create that framework and that architecture. It doesn't define a user interface. There are tools that you can use to build up UIs, and AES-70 will certainly help you along with that, but it's not a rigid framework for software or HMI interfaces for the system. It's just an enabler. It's not a full stack media networking solution, so it's only looking at the transport. And one thing that I think is also really important to emphasize is when we talk about things like parameter control, AES-70 provides the framework for describing and interacting with those parameters, but it doesn't do so at an algorithmic level. So you're still free to build up any type of DSP algorithm that you want, have that device work however you want, not advertise that to the world, but it gives a common way that you can express this and explain it so other devices, other controllers, and other products can interact with it. As mentioned at the beginning, and I just want to touch on this one more time, sometimes the terms AES-70 and OCA get tossed around somewhat interchangeably. That was because we actually began to see products implementing the technology before it was formally standardized by the AES in 2015. We needed something to call it in the interim, so Open Control Architecture was the name that was chosen at the time. We have since started to use the term OCA to describe the ecosystem of tools and products and technologies that implement and support AES-70, but informally, those terms get used fairly interchangeably. We're not pedantic about it. So however anybody wants to refer to it, that's absolutely okay.
So AES-70 is a control. It's a networking tool. It's not necessarily the whole tool set. It's a tool that you don't necessarily. If I try to compare it to something like Dante, you have to have the whole set of things, everything, and you're controlling things, but also streaming things through Dante. But with AES-70, you're basically the control tool, and you don't need to necessarily have a full set of any of it, other than be able to connect to something that has a full set of tools. Is that an accurate way of saying it, or am I misunderstanding?
Yeah, I think it's an accurate way of saying it. Dante's primary reason for existence, as we just talk about the
Yes,
technology,
right.
is fundamentally as a transport, but it does also have elements of control inside of it.
Right. Yeah.
That's how we're able to, I mean, that's what Dante
Right.
controller is
Hmm.
actually doing. It
Exactly. Yeah.
establishes those connections. It's able to monitor your clock. It
Right.
has some of that functionality, but it doesn't go so far as to directly control all of the parameters and all of the elements within your hardware.
Good.
So yeah, there's a bit of an overlap as we get into this control domain from one solution to another.
But this seems like a more maybe an easier entry or an easier tool to use rather than try to dig into the details that might be specific to a type of, network or a content streamer or what have you. So
Yeah,
I think
well,
that
as I say, they're aimed at doing slightly different things.
got it.
So,
Okay.
with
Go
something
ahead.
like Dante or Ravenna or 2110, the core reason for its existence is to move that content around. So it's fundamentally a transport.
Right.
There
Transport.
are elements within those solutions that also touch on control, um, just because something had to be there to get that functionality. So you had to have sort of that base level
Mhm.
of control within that solution offering. And that's one of the reasons that I talk about things like Dante or Ravenna or Milan as solutions rather than
Right.
standards.
Got it.
They're also not regulated by a standards body, but they go beyond just moving the ones and zeros around, and they do offer at least some fundamental level of control. AS70 kind of goes the opposite direction. It's all about control, and goes much, much deeper than any of the transport uh, functionality, but it really doesn't care what transport, if any, it's being used alongside.
That's
And
good.
as we'll talk a little bit about, we also are able to extend some connection management and transport control functionality inside of the standard as well, with some of the things that we're working on now and throughout the coming year.
Good. Okay, good. Sorry. Good.
So some of the design goals that we had with AES70 when we were really digging into it, as I say, we looked at as much that was out there on the field already as we could, because frankly, if there was already something that existed that did what we needed it to do, we could have saved ourselves a whole lot of time and grief and money and
Right.
just said, cool, that one works, go with that. But everywhere we looked, there was a shortcoming that we found. And that's not to say that any of the existing solutions or control technologies that were out there were bad or deficient. They just didn't quite fit the design criteria that we had for AS70 and what we and our constituent members of what would become the OCA Alliance really needed. We wanted something that was suited to professional applications, could support multi-vendor systems, could support multi-controller systems where you had many points of interaction, different people looking at different screens or hardware interfaces and interacting with the same device at the same time. We wanted it to be able to scale, but importantly, scale up so we could have international, connections of tens of thousands of devices, each of which had tens of thousands of parameters that could operate simultaneously, but also be able to scale down. So something could be very, very small and implemented in a lightweight way on a very inexpensive and compact microcontroller or piece of hardware. So it needed to be big and robust, but it also needed to be small and light. And that's a really big challenge
Mm.
with a lot of technologies. Um, it was important that it could operate mission critically. So we needed to have a high level of reliability. We needed to deal with things like encryption and security support. So mission critical applications could be secure. And most importantly, we needed this to be able to operate in the real world as well as the virtual world. So a good solution for hardware as well as software and controllers that could exist and coexist with each other. Had to be efficient. It had to be product friendly. So we needed to strike the balance between flexibility and complexity, between standardization and freedom. So when we got into defining things like object classes and trees, we wanted to be able to choose something that would be flexible enough that a developer would be able to implement something that was maybe a non-standard function or non-standard DSP parameter inside of their device, but also in a way that other systems could see it and understand it and have this presented in a human readable way. So finding that balance between standardization of implementations and object classes, but also flexibility was really important to us. A good example of that would be in the object classes, we present and offer up strongly typed objects. So you could have something like an OCA.gain, which does exactly what it says on the tin. It adjusts the gain up and down. But there are also loosely typed objects. So you could have a float or an int or a Boolean. If there's something that you need to have a little bit more flexibility on, all of that's fair game, and all of that's defined inside of the standard. So you have the flexibility to implement it however you need, but you still retain that interoperability and understanding across the entire ecosystem and with the other controllers that are out there. And one of the things that you mentioned earlier, Roger, that I think is important to come back to is one of the fundamental benefits that you get from going with a standardized solution that's backed by an industry standards body is, number one, it's something that's going to have some longevity. So there's an organization that's going to continue to support and maintain and develop that protocol and, well, that standard and those protocols that are used. But as an engineer and as a developer, you're also getting a force multiplier here, right? If I, as a developer, am going to sit down and try to build up a control architecture and control protocol from scratch, I'm staring at a blank sheet of paper. It's going to be a long, rough road to hoe. But if I can go to an organization that's had a solution that's built up by dozens or hundreds of other engineers that I don't have to pay, that's a really, really big advantage. So I'm getting all of that expertise essentially for free. I'm getting that maintenance, so I don't have to manage the ongoing technical debt of developing and maintaining the technology, and I can get that product out faster, more efficiently, and get to product orders a lot faster than I could if I was building this from a blank sheet of paper. So just a real quick overview of some of the features that exist behind this. AES-70 has become a pretty comprehensive piece of technology. So basic device and control functionality, discovery and enumeration, so I can plug a device into a controller. The controller can actually discover and see all of the parameters that are in there. So that is an amplifier from D&B, and it contains these objects. Here they are. Everything's presented in a human readable format. Device structuring, connection management for nailing up and tearing down media network connections. A number of other functions and features that are inside of the specification. And one thing that's really important to understand about the technology, when you look at AES-70 at the beginning, there's a lot of documentation there, and it has a tremendous amount of capabilities. But it's important to understand that you, as an implementer, do not have to use all of it. You don't even have to use most of it. The fundamental minimum implementation of AES-70 is incredibly compact, and we're able to get that on something as small as a Cortex M3. We can run it on a Raspberry Pi. It can be very lean and very lightweight. So I always give that caution up front that when we talk about what it can do, it's exactly that. Can, not has to. So these are options that you as a developer have, and it's really a menu of things that you're allowed to choose from. But the things that you have to implement are actually very small, very minimal, and very easy to do.
That's got to be a very good feature. I mean, that's, really something. Simplicity is, a key in product development, as we know. So
100%.
Yeah, that's a very good item to identify.
Yeah,
And
well,
also,
I'm sorry, go
I
ahead.
was just going to say, it also seems like something that is very cohesive with the pro and install market versus consumer market. So when you mention guys like perhaps Logitech bringing in unified communications that might run on this protocol, historically they were always kind of make their own standard, perhaps. So it's kind of interesting to see how that comes together to make it cooperate.
Yeah, well, I mean, the interoperability is a really important thing. And one of the challenges that control has versus things like some of the media transports that are out there, as I've been saying, control is really fundamental to the heart and soul of your device. You're defining what it is and what it does. So it's something that is important to consider from the beginning. That's not to say that you can't add it onto an existing product or implement it into a product later on. A number of the OCA Alliance members, notably Focusrite, have done exactly that. They had an existing product and an existing product line and implemented AES-70 as a complement to their native and bespoke control protocol. That's absolutely fair game, but
Okay.
it from an implementation standpoint, it's always easier to do when you do this up front because it does get so deep into your product architecture. Not to discount the complexity of implementing media transports like Dante or Milan or something else, but that's something that you're sort of adding to the back end of the device. I just take my feed off of my TDM bus and I plug it into this solution, and then that handles everything going out. Control gets a lot deeper, both going into and coming out of the device itself. So this is one of the reasons that when we look at things like adoption curves, AES-70 has been very steady, but it's been slower than what you've seen with things like media transports. It's simply because the implementation into the device takes a bit longer to get that real holistic solution. And that has just continued to grow, particularly as new markets and new implementers have looked at it. So I guess just I'm not going to go through all of this point by point, but again, to get to my earlier point about being able to pick and choose what and how you want to implement, these are just some of the options that you have within AES-70. How do I want it to run on the network? What types of networks do I want it to run on? What types of implementations? Control transport, TCP, UDP, WebSockets, point-to-point. All of these are fair game. You could use some or all of these. All depends on what's exactly right for you and for your system and the product solution you're trying to develop. We're going to dig into a little bit about the AES-70 standards family. AES-70 is certainly a individual standard, but it's a suite of documents and standards publications that complement each other and build on each other. So we have this broken out into sort of two categories, what we refer to as the core standards family, which would be AES-70-1, which is the framework. AES-70-2 is really kind of the meat and the biggest part of the standard itself. That refers to the control model. What are the objects? Things like the actuators, the managers, the specific objects that I'm going to use to describe and enumerate a function within a device. This is where I'm going to find things like my mute controls, my filter controls, my power controls, my power monitor, VU meters, that type of thing. AES-70-3 is the binary protocol for how we're going to move that across the wire. So TCP, UDP, WebSockets, those type of elements. We're working on a AES-70-4, which is a JSON protocol to be able to just package this up as another way to deliver the AES-70 solutions themselves. This is in work as we speak, and that will be coming soon. And then also incumbent in the entire core technology is what we refer to as CM4, or Connection Management 4, which is a generic connection management scheme. That then plugs into the more specific documents that we refer to as adaptations that are specific ways that I can create and implement connections for media streams between different technologies. So AES-70-21 is supporting connection management for AES-67 and ST2110 streams. AES-70-22 is for connecting Milan streams, and AES-70-23 will be using AES-70 to connect Dante streams. Audinate is in the process of rolling out some new APIs and ways that they want to work with this. So they've been collaborating with the AES and the OCA Alliance to help make sure that that adaptation is done to support both their current and future technology plans. But these, again, are specific elements that go into how we work with connection management. And again, they're optional. So if I'm never going to use a Dante device with my product, obviously I don't need to worry about implementing the Dante adaptation. So just an example of how you can walk up to the standards buffet and take a little of this, a little of that, and choose what you want.
Great.
To talk a little bit about the connection management operations that are in here, as I mentioned, when things like AES-67 were being defined, there were some thoughts that were given to connection management, but there's not actually a full software implementation to be able to do that at the time. So we, as we were developing AES-70, wanted to look at how can we actually support media stream connection management, which was particularly important to us because, as I say, AES-70 being agnostic as to what transport media was going to be used, we wanted to be able to allow our implementers and our users to really talk to anything. So the core technology itself supports this primitive generic connection management stream to be able to nail up and build up and work with these connection managements. Those will be supported in the future and currently are by the adaptations as they begin to roll out to be able to get more specific and more bespoke and feature-rich connection management functionality within a solution. Just to sort of walk through the list of standards that are out there again, this is something that I'll let everybody read silently and I won't walk you all through it. But I do like to put it all on one slide just so everybody can see what's out there. And again, this can sometimes look a little bit intimidating because people will look at it and say, oh my gosh, I really, that's a whole lot to try to ingest and take in, and I don't necessarily want to get through it all. It was broken up this way so we could continue to work on individual elements of the standard independently of each other. For little inside baseball when it comes to how some of these standards actually work. When you're going to make a update to a standard, there's a very long process of drafting and review and formatting and public comment and a number of other things that go into it. So if we wanted to make just a really simple change or extension to the network protocol, for example, we wanted to build this JSON version. If everything was contained in one document, we would have to go through and revise the entire publication and go through it all. This gives us a more atomic, object-oriented, if you will, way of being able to work with the standards documentation. So we can make changes and updates where needed, as needed, and be a little bit more agile to do it. It also makes it easier for us to extend and add things on, such as the connection management adaptations at the back end. So the dates here for what's available, AES-70 1, 2, 3, 1, 2, and 3 are published and are available. AES-70-4, which is the JSON version, we're targeting probably Q2, maybe a little bit later this year. We'll see how the process goes. The AES-67 ST2110-30 adaptation, we're targeting towards the end of the quarter. I believe as we are speaking today, that's in public comment right now. The Milan adaptation, AES-70-22, has been published, and as I mentioned, the Dante adaptation is future work.
Awesome.
So just to wrap up here, just a couple of resources for everybody that's out there that's interested in learning more, maybe getting your hands on some of the technology that's out there. As I say, when we use the term OCA now, we're generally talking about the broader ecosystem of information and tools and products and technology that supports AES-70. So you can find us at OCAalliance.com. We also have a GitHub site, which contains a number of technical tools and resources at OCAalliance.github.io. Of course, the home, the ultimate home for all of the standards themselves is the AES. So you can find the formal, most current documents available through the AES. Those, of course, are available for free to AES members and for a nominal fee to non-members, should you be interested. There is a LinkedIn group where we publish information and have informal conversations amongst the community that uses and implements AES 70. And one thing that we always like to reference is you can also get information on joining the AES standards group, which again is SCO212L. Rolls right off the tongue. You do not need to be an AES member to join that, but you can participate to get the inside scoop on what's up and coming and actually help shape the standards if you are so willing.
Great.
Oh yeah, I'm sorry. Go ahead, Steve.
No, I was going to say that's very good information. Very good.
I have a question from the chat that I'm going to pass
Yeah.
on to you, and because I don't understand it.
So, okay.
How does AES 70 relate to and live next to NMO? I'm sorry, NMOS,
NMOS.
NMOS and AMWA. Can they merge? Question mark.
That's a really great question. Yeah, and NMOS is for everybody who is not familiar with these. When we are looking at some of the standards and standard suites that are existing in the broadcast world, the I guess main technology suite for transport that's really sort of coming in is the SMPTE ST2110 suite of standards. That is supported by a group of technology offerings from the Advanced Media Workflow Association, AMWA, that refers to them as NMOS. So these are a number of technologies that are responsible for operations on the network itself. Everything from connection management to discovery to some actual control functionalities. It's a very friendly group, and we do have regular conversations and interactions with the AMWA developer teams and certainly the other groups on the AIMS side of things that are looking at how do we define these things coming together. NMOS and the relevant technologies were defined a little bit differently than what AES 70 was done, or how AES 70 was done. So it's not really feasible to do a direct merge, but we're constantly having conversations about how to begin to maybe bring those things a little bit closer together, to offer some of the more feature-rich options that are existing within the AES 70 capabilities, but certainly respect the way that ST2110 operates and the way AMWA and the NMOS suite works as well. So I guess the short version is it's an ongoing discussion, and certainly we're very encouraging to both groups to try to work to harmonize those things where it makes sense. There are certainly arguments to be made for doing things a specific way. That's okay. We're not on a imperialistic march to try to take over the world of control and standards. We really want to get things to work together.
Oh, good. Thanks for answering that one. I think hopefully that was helpful to the DP in the chat there. And then now you have libraries on the screen, so you're making sure that everybody knows it's available for at least those 3-4 languages. So
yeah, exactly. You can get your hands on some of this and play around with it if you want. So there is a JavaScript version, a C++, C#, Python. Some of them are open source. Some of them are commercial. So if you're doing a actual commercial product, you've got options to choose what you want. There are a few other things that are out there that are floating around, and honestly, this is one of the reasons that I am so optimistic about the future of AES 70, because we will wander around trade shows or go snooping around in GitHub, and we'll see implementations popping up that we knew nothing about, and that's fantastic. Our mission is to just get people to use it and give it to the industry and let the industry take it away as it sees fit. So these are some of the software libraries that are available. There are a number of software tools that are available. AES 70 Explorer is a UI development tool where you can plug in AS70 device. It'll actually enumerate all of the objects that are there. You can build up a custom UI with it to play around with it. There is what's referred to as an AS70 compliancy test tool. So if you're implementing or trying a test implementation, you can just run that against the test tool to make sure that everything is working correctly. If it is, it will let you know. If it's not, it will tell you what you need to change. So it's a way to test implementations. There's a Wireshark plugin. There is a virtual device. There are a number of other things that are existing, and many of these can be found on that ocaalliance.github.io website. There's this and more, but all of this is free. We want to make this available to the developer community. There
Great.
is also a hardware reference design also on that GitHub site.
Oh, great. That's it. That's great. I appreciate maybe this is not a good summary, but maybe my take on what AES-70 is that if anyone's ever tried to set up a home network, that you suddenly run into IT issues or needs that your ordinary consumer doesn't have a clue about or doesn't have. And this is a way to get away from having to be an IT engineer to listen to audio. I mean, the ultimate thing is to listen to audio, right? Or see a video. So I think the whole idea here is to simplify the development of a product that makes the end user happier, and that makes sure that your product gets into more hands, even if maybe it's at a pro level where you've got some professional installation, but on a consumer side, this simplifies it, I think, a great deal. So I think that's
well, one of my favorite things about the technology, and I come to this from the old school way of doing system integration and having to design converged systems back in the good old days of 485 and CAN
right.
bus and all sorts of stuff that old guys like me used to have to work with. You know, the API and the objects that are published by AS70 are human readable. So it's not a jumble of hex. It's not some weird object ID. I can look at a device enumeration inside of AS70 Explorer, and it will say OCA.gain, OCA.mute, OCA.filter. So I know exactly what it is and what it's doing. And that seems like a really small thing, but for integrators or people that are trying to build up custom controllers or people who are just trying to understand what's going on in my device, that is so valuable. And
Yeah.
this again was our motivation. How do we take the rough edges off and reduce the friction so people can get their products to market faster and have a better development experience and their users can be happier? That
Yeah,
was the goal.
you don't spend the day learning, you spend a day developing. So that's
Yeah,
good.
exactly.
Yeah.
I,
No.
I
And
agree.
that is the key.
Yeah. Great. That's wonderful. I think we've covered most of things that we were being asked about. There you go. How to get a hold of folks. I'm looking for you. There you are, number 2.
I'm in there somewhere. Yeah, Jeff's the more important one.
All right. This is great. Thank you so much. And this will be up on our channel. So anybody who missed it or wants to share it, please go ahead and do that. Like and subscribe as well to us so that we can continue. We're both nonprofits, so we appreciate all the help that we can get from anyone outside the organization for the APDA or the OCA. Appreciate everything. Thank you again, Ethan, for coming on today and giving us a deeper dive. I think this is great. This is wonderful.
Thanks so much for having me. I really appreciate it.
And I'm not sure you'll be anywhere in specifically, but you'll be working on all the things you just said you're doing. So if you're out in the world and you see Ethan walking around, say hello to him. You'll probably be attending some of the shows that we all do. So if you see him.
Indeed, yeah, I will probably pop up at Infocom. Again, I live my world. I live predominantly in the pro world, so
Yeah.
Infocom, ISE, of course, is a big show for me, and
Yeah.
you never know.
Oh,
I'm
that's
a
right.
strange looking person, so I pop up in random places.
Okay, we appreciate it.
Thank you, Ethan.
Appreciate
Thank
that.
you all. Appreciate it.
Once again,
Okay.
a reminder of what we've got coming up in a few months. We've got April with Fraunhofer, May 6th with manufacturing in the South Pacific Asia, and then later in June, the Audio Foundry. Bluetooth LE audio in July, and then back in August on tariffs. Again, I appreciate it. Like and subscribe us here on YouTube, on our YouTube channel. And until we get together again next month, well, we're happy to have you guys with us. And thanks again, Ethan. And thanks, Dave and Steve, for joining us. I think that's it for us today. Appreciate it. Thanks, everyone.
Okay. Thank you.
Bye-bye.
Bye-bye.